Here's our cutaway of a 671 supercharger, and I just want to do a little bit of an explanation on how a supercharger works and give you a little bit about the characteristics. This being a 671 supercharger that displaces 411 cubic inches of air per revolution. So that's one complete full revolution of the supercharger will move 411 cubic inches of air. This particular supercharger is a billet rotor, and this has our high helix rotors in it. Typically they would classify that as a 120 degree rotor, but that's going to be if it was a 1471. In a 671 being 6.5 degrees of twist, that gives it, I think it's 97.5 degrees of twist on a 671. A standard GMC Detroit Diesel 671, which has a 60 degree rotor, that is 4 degrees of twist per inch. So this is a high helix, giving a little more twist. And the advantages with the high helix is it's less horsepower to turn the supercharger, and it also gives it a cooler outlet temperature. So there are some advantages with the high helix over a standard 60 degree. Now this particular supercharger, this is what we would call an 18-point Teflon. So that means it's going to have a total of 18 strips of Teflon. So there's going to be 3 per lobe. So you've got the Teflon, the OD, and then the Teflon that's going to be on the side of the rotor, or what they call the hooks. The Teflon on the side on the hooks is going to seal rotor to rotor. So you can see where this Teflon strip here is going to seal across the rotor in this area. So 18 point for the hook Teflon seals rotor to rotor. The Teflon on the OD is going to now seal rotor to the case, and you can see where it would seal to the case on the side here. As far as air movement in the supercharger, as this is rotating, this lobe is coming out of this valley, and that's going to start creating a vacuum to start sucking the air into the supercharger. So as this is filling, it's filling from the back first and moving towards the front. The other characteristics with the helical rotor is you can see how this is this air is going to be moving through the case on the side, but as the rotors come together, it's actually going to move the air towards the front of the supercharger. So as the supercharger rotates, we can see the lobe on the lag rotor as it is coming out of the valley on the drive rotor. That's what's drawing the air into the supercharger. So as it continues to rotate, it fills this valley and then seals to the side of the case. It then now has a trapped amount of air that's going to, as it continues to rotate, and as the rotors come together on the bottom, it squeezes the air out of the supercharger and into the intake manifold, and that's how you generate your boost.